The goal of this model is investigating whether this investment is worth pursuing or not. We will be doing that by looking at the net present value of this particular investment over the next 10 years, from 1999 to 2008. I have created a spreadsheet here that will help us with that analysis. If you look at the template, we could already see some of the spreadsheet engineering principles at work. I have all the parameters in one place. They're all coded in blue. All the numbers I have been given have a label with them, and I try to make it as descriptive as possible. What does this model do? In this model, given the prices of the competition and given the price decisions of our company, we first come up with a price ratio. We examine how the overall market will grow in the next 10 years. Then, based on our price ratio, based on our customers' price sensitivity, we figure out what our market share will be. Then, based on the market size and market share, we figure out how much of the market we will get and how many balls we will sell. And based on how many balls we sell and our selling price, we will be looking at profit. Once we get profit figures for all 10 years, then we will calculate the net present value of this investment based on discounted profit, cash flow, and our initial investment. And of course, we will be considering the discount rate of 10%. In this particular analysis, the most crucial part of the model is how to examine the relationship between price ratio and market share. In the textbook, you will see that the price ratio and percentage of buyers is given as such. So the price ratio is our price divided by the competitor's price. So if the price ratio is 0.5, this means we're selling our balls twice as much as the competitors. And in that case, you see that we don't get any of the market. But if we can price our balls 1/3 of the competitors, then we will end up getting the entire market share. The question is, where should we be in this price ratio spectrum? Now, if you choose a price value that will give you a price ratio that is one of these 6 values, 0.5 through 3.0, then the percentage of buyers that will be buying your balls is easy to find out. But what if I wanted to figure out what happens if my price ratio is 1.4? Well, I know that 1.4 falls in between 1 and 1.5, so my market share is going to be somewhere between 11% and 41%. But what would that figure be exactly? What would my market share be exactly? Is a harder question to answer. In order to be able to answer that question with a bit more precision, we need to think about several models. You can create an S-shaped market share curve. You could do a linear approximation and interpolation between each endpoint of these intervals, or we could try to fit a simple 3-degree polynomial to these 6 numbers. What I will do is show you 2 different models. One based on the 3-degree polynomial, then we'll look at how to handle this using linear interpolation. First, let's plot the data points we're given to see what the data looks like. I highlight my price ratios and my percentage market share I go to Insert. Under Insert, I will go to Charts. Under Charts, I'm going to choose Scatter. And under Scatter, I just choose the first one. And again, it would be ideal if I properly named everything, but for now, I'm just going to show you the basic idea of what's going on here. Now, as you can see, this is actually a S-shaped curve. If you price your balls more than twice as much as the market, then you are not getting any market share. If you price the balls cheaper than 1/3 of the competition, then you will have the entire market share, and your market share shows an S-shaped in between these two end points. Now we're going to try to fit a 3-degree polynomial here. In order to do that, I right click on one of my data points. I go ahead and choose Add Trendline. As you can see, I get immediately a linear trend line here, but I'm not interested in a linear one because that doesn't capture the relationship. What I will do is go and choose a polynomial trend line. The default in polynomial trend line is a second order polynomial, but as you can see, that curve doesn't capture my S-shaped well. So let's increase the order by 1. This is a third order polynomial. It is not a perfect match to my data sets, but it's a fairly reasonable one. So I will go ahead and use this. In order to figure out what equation determines this particular third order polynomial, I need to go under trend line and choose the option Display Equation on Chart. Let's go ahead and move it around so we can see it a little bit better. I'm gonna go ahead and close this. So now I have a formula that tells me what my market share is going to be, more or less, if I know what my price ratio is. So what I will do is I will get this formula and type it in B9 here. I have my formula. Now I push enter. It gives me a reasonable approximation. For 1.4 price ratio, I get 34.56%. That's between 11 and 41. It's closer to 41. So it's somewhere here. It looks like a reasonable approximation. Now, a particular problem with this third degree polynomial is that I will see some unusual results around 2.8 or so, and then I will also see some weird results when I go beyond 3 for my price ratio. Let's first see what happens when I put, for example, 2.8 for my price ratio. As you can see, when I put 2.8, I'm gonna get more than 100% of the market share, which is nonsensical. That's exactly because of this bump here. Or if I had a price ratio of 3, I get almost 100%. But if I get a price ratio of 3.5, I actually go down to 66.95, which doesn't make any sense because I'm making my product cheaper and all of a sudden my market share is going down. But if you are careful and if you use this model only between 1 and 2.5, so 1 and 2.5, then you get a fairly reasonable approximation to what the original table gives you. As a side note, this price ratio versus market share cannot be a precise model anyway, so you don't necessarily need to have a precise fit to these 6 data points that you came up through some forecasting analysis anyways. Now this is model 1 for the price ratio versus market share. In the next video we will be looking at another model that captures this relationship.